It's a couple days later, and I've had an opportunity to talk with the factory a couple times that makes the three-phase converter and have some interesting information from them. Welcome to 3D Accuracy, where I'll talk about 3D printing, 3D product design, and 3D injection and die-cast mold design. Let me show you what we talked about and what I'm going to do with the machine today to see if I can get this up and running. One of the challenges with a three-phase converter like this is getting the voltages to be stabilized in the same across all the connections. It's almost an impossibility to do that when you have a three-phase motor involved that's generating that third leg of electricity. It always tends to be higher and can cause an issue potentially. So what we discussed about doing was to perhaps put a transformer in line from the main power cable that comes from the three-phase or from the sub panel across the shop. Put another transformer in here to knock this voltage down a little bit and come in on the low side of the voltage instead of in the middle. Now, that would require purchasing an item, a transformer, roughly $250, plus figuring out where in the heck am I going to put that thing and how to install it, because they're not real heavy, but they're not light either. So that was a little bit of a challenge. Then we got discussing some other things, and the fella that I talked with at American Rotary, James, really nice fella, very knowledgeable, very helpful. He said, let me check and see what else we might be able to do. So he comes back to the phone and he says, are you by the three-phase panel? I said, yes, I am. It's open and I'm standing right in front of it looking at it, just like we're doing right now. So he says, okay, we're going to try this. Up in the upper right-hand corner, this one right here, there's a capacitor. Disconnect the two wires that come from the capacitor below and then loop them back in and plug it into the open terminal just so that they're not open and exposed. And take this one capacitor, this guy here, out of the system. So I did that and then turned on the three-phase, got that going, then checked the voltages up here at the machine at the T1, T2, and T3 terminals, checked across each one of them, and also checked the wires back here at the back of the machine. So let me show you what those numbers turned out to be. I have them all written down over here. Okay, at T1 and T2, it came out the same, 241.5. I didn't even bother to write it down. Between T1 and T3, which is the manufactured line, it dropped down to 253. Across T2 and T3, it dropped down to 257. Now, then I went and checked it after it comes through the transformer, and I checked what are the voltages at the back of the machine on those bare wires that I took out the back. From A to B, it was 232, right in line, perfect. A to C, 243, right at the high side. And 246 between B and C. Now, plus or minus 5% gives me 241.5 volts for the machine. So at the maximum, this is 5.5 volts more than it should be. Now, there's an issue with should be, because once the machine is up and running and creates a load, those voltages are going to come down. They're all going to balance out so that they should be within the range that the machine will work with no problems, which is between 219 volts and 241.5. That's what it is. We're targeting 230, but it's plus or minus 5%. So those voltages that are a couple of volts above should fall into line and not be a problem. So what I'm going to do, now that we have the voltages a little bit closer to where they belong within a reasonable range, I'm going to reconnect these wires that I disconnected the other day. I'm going to reconnect these wires to the machine, and I am going to put them the way they were originally, where the white is connected to the L1 terminal on the right and the black to the L2 terminal on the left, and the L3 terminal on the left, and the red connected to the L2 terminal in the center. I'm going to connect it exactly the way it was before because it really shouldn't make a difference. At this point, it's providing approximately the same amount of voltage to every terminal. So I'm just going to leave it the way it was. And then I'm going to fire up the phase converter, and then we'll turn on the machine and I'll check the voltages up here across those terminals. You can see right in the middle of the screen there, those 5 terminals. I'll check the voltage there and see if we can get this machine booted up. Okay, so I'm going to pause for a minute while I get these wires connected back up, and then we'll see if we can get this running. The wires are reconnected to the connector, the wires that come from the transformer, and the circuit breaker is on. The circuit breaker is on and the switch is on to allow the battery into the system. Now the battery still has no response, no life to it, but I can hear it ticking. It is the battery that's doing that, making that ticket, ticket, ticket. So something's wrong with this battery, which is okay. I'm going to replace it anyway. That I don't care about. Okay, so let's go around the other side of the machine, and I want to check the voltages that are on the connections back here. So let me get my little voltmeter here. Let's go over here and see if I can hold the phone and check this at the same time. I may or may not be able to do that. Let's see. Okay. First, we want to check from A. This is terminal A, this is terminal B, this is terminal C. This is the neutral, this is the ground. We're going to check across these, this one and this one, this one and that one, this one and this one, and then we'll also check from each of them to the ground to check the voltages. So first we'll check this guy. Okay, and down there you can see we have 246 volts, 246.7. Okay. From A to C, we have 242. And from B to C, we have 230 and a half. So those seem to correspond with what I had here when I checked the wires on the outside. 243, 246. So we're getting the same readings in here, except I think the wires are reversed because the black and the whites were reversed. And these voltages, I actually took these from the wires before they were attached, but we're coming in line. We're the same. We're right about in the same voltages, so I think we're okay. So let's check from the A to the ground, B to the ground, C to the ground. We should be between 100 and 160 volts. Before, these two were okay. They were 142. This one was way too high. So let's check and see what we have here now. Okay, so let's get my little tools here, see if I can do this and hold the phone at the same time. So from here to the ground, we have 219. That's way too high. From B to the ground, we have 115. C to the ground, 115. This is 100, 219, 218. So this is still too high. Better than before. 218, 115, 115. That's what we have now. That one I don't like. Should be 160, it's still high. Okay, which means there may be some sort of a problem in here. What it is, I have no idea. So, not sure what to do except make a couple of phone calls and see what can be done. Why that one should be so much higher than the other. Now, A, strangely enough, I believe is the manufactured line from the three-phase converter, because the black and the white wires are crossed. So if black would be the first one in line and white would be the third one in line, they're reversed. So that white line, the manufactured line, is on terminal A here because of the way it's wired down here. If I reverse those wires, I probably get the same voltage readings, just opposite at different terminals. Okay, have to think. Well, I decided to go ahead and reverse the black and the white wire where the cable comes into the back of the 3D printer, where the black and the white seemed to me to be switched. I decided to go ahead and flip those. Put the black on L1 and the white on L3. And then I remeasured the voltages across the terminals here on the side. And let me show you what those numbers turned out to be. What I ended up with after I swapped the numbers, or I'm sorry, not swapped the numbers, swapped the wires. From A to B, I ended up with 229 volts, which is perfect. From A to C, I ended up with 241. And C is the manufactured line from the idler motor. From B to C, 245. Again, C being the manufactured line. So these numbers dropped a couple of volts, 1 volt here and 2 volts here. Then when I got to measuring from the terminals to the grounds, I got pretty much the same results as before. They dropped 1 volt, and of course because I switched the wire, you see the manufactured line, instead of being on the A terminal, is now on the C terminal, and this is where it comes out. This is still too high, this 217. It needs to be 160 or less, between 100 and 160. Why these numbers come out pretty darn close to where they should be. I mean, within 3.5 degrees, or 3.5 degrees, 3.5 volts, within 3.5 volts of where it should be at the maximum, plus 5%. So it's very, very close, at idle, with no load on the system. Why it would jump up on this one, on the manufactured line only, I have no idea. So the only thing I can think of offhand is inside the power supply here, there must be some sort of a transformer, some sort of a something that regulates the voltage, and it's out of whack. Maybe that's what popped when I started up the system that one time. Maybe we blew a component in the power supply. I don't know. It does come up. The only thing that does not come up is the battery, and it's just making a clicking sound. So I think if 300 volts went to that battery, it may have toasted some of the electronics or tripped something. I don't know if there's a circuit breaker on that battery. I would think they might do something like that, but I'm not sure. So I've got to talk with the manufacturer of the battery, see if I can get that back in the system, just to see if it regulates this voltage somehow. But I don't really know. So I need to make a phone call in the morning. It's already too late for Midwest, East Coast time. So that's where we're at. I hope you really enjoyed this video. If you're ever in need of 3D product design, 3D injection mold design, 3D die-cast mold design, or 3D printed prototypes or production parts, please feel free to contact me. You can find contact information in the video description. I look forward to hearing from you and to being of service to you. Thank you for watching. As always, I appreciate it. See you on 3D Accuracy's next video.